students, today's agenda is to check homework. We'll be solving equations with graphing technology, and you will be able to do 5.8. Today, students will be able to find the solution for sets of any arrangements of equations using technology. And for this lesson, you can use your TI-82, TI-83, or TI-81. However, what I'm going to do is that I'm going to show you. You can go to Desmos.com. I'm using Safari, but you can use other internet. And so in here, you just press Graphing Calculator, and you're going to write the equations that you get. Number one, and even if it takes a little longer, I want to take the time to show you how to write it. And you can have it like, or you can turn it around. It's up to you. You can try different things. So for this function right here, what we're going to do is just press X. You have a squared, which will automatically create a parabola, but that's not what we want. So let's go back. This is to erase whatever you write. We're going to have a to the b power, and that brings it up to give an exponent. So we press the 4. Then it has minus. We're going to use these arrows going to the front to make it bigger because it's still in the exponent mode, okay? And so after that, it's minus 4x, minus 4x. And then again, it's an exponent, exponent 3. Okay, so again, we go a to the b, and the exponent is 3. Look at what's starting to form now. But we're not finished, so let's go back to the keyboard. Again, it's already, if you notice, it's already big. And so that's plus 2x squared plus 2x squared. This time we can use automatically the a squared plus x plus x minus 1 equals -1. So in here, something that I want you to do is before we're not going to plug anything else, because if you notice, by adding 1 to both sides, this will cancel, and that's all you are left with. Okay, the x to the 4th minus 4x cubed plus 2x squared plus x. So now, what I want you to do is go back here to your graph, and you can manipulate it, okay, and make it bigger. Notice how if you keep touching it, some points, grayish points appear in there. So those points that cross in the x-axis, those are the solutions that we are going to be looking for. Solving equations with graphing technology. Solving just means find the value of x. So now we press the points, and for x, it's -0.3, -0.3. So that's one of the solutions. The other solution is this one right here. This is not a solution. This is just one of the minimum and maximum. In this case, the minimum local minimum. In here we have 0, 0. We only take the x, so x can also be 0. For the next one, x is equals to 1. Then we go over here, and finally x is equals to 3.3. Positive 3.3. So something that I want you to recall from previous lessons, the biggest exponent or the biggest degree, the degree of the function will tell me the number of solutions. Sometimes they're imaginary and they don't appear, or they don't go through x, but in here we have 1, 2, 3, 4, and we have the exponent 4. Okay, there they are, 1, 2, 3, 4. The next thing that you will be doing is that you're going to sketch the graph in your homework. Okay, let me see where I can move it. I'm going to put up to 5. In here it goes past 5 but less than 10. So it goes on negative 0.3. So we have negative 1. Negative 0.3 will be around here. We have the 0.0. We have 1 and 3.3. So 1, 2, 3, 4. So this is 2, 3, 4. It also goes through 3.3 around here and 1. So those are my 4 points right there. Now I look at the graph here and I notice that it goes something like this, very close in here. Then it goes up and then down again, and then it goes down and up. And so that's what you're going to be doing for your homework. Okay, it's not perfect, but it's that's why it's called a sketch. If you use pencil, that will be easier to erase, or those erasable pens that are magical now. There you go, more or less. Okay, so let me make it smaller so you can see. If you can add more, that's fine. Something like that. Okay, so but how can we find this algebraically? Let's try. We're going to be using different concepts that we learned in the past, and so this will be very great review for you guys. Okay, technology to the side. Okay, now that we eliminated the 1, let's rewrite that as x to the 4th minus 4x cubed plus 2x squared plus x equals 0. And so the first thing that you want to try is the greatest common factor. Do we have anything that we can take out from that function? And so, yeah, all of these have x. So, and that's the smallest exponent. So we're going to put x and start dividing each term by x. So x to the 4th divided by x. Remember that in division, we're dividing to find the other factors. So in division, we keep the base and subtract exponents. And there is nothing in here, is the chiquitito, the number 1. So keep the same base, subtract exponents. 4 minus 1 is 3. Or you just say x to the 4th divided by x is x cubed. The negative divided by positive is negative. 4, because this is like we have a coefficient 1. 4 divided by 1 is 4. And then again, x cubed divided by x to the first power is x squared. You're just subtracting that 1 that we don't have in there. Then 2 divided by 1 is 2. X squared divided by x is x. Positive divided by positive is positive. X divided by x is 1. And that's all for now. Now, some people get confusing here and they put x divided by x is x. No, because there is also a chiquitito in there. And 1 minus 1 is 0. X, or anything to the power of 0, will always be equals to 1. Okay, so that's why it's 1. Okay, in here we cannot, I try to do grouping. If you do grouping, remember that you have to divide in here the greatest common factor. We're ignoring this part now because it's already a factor outside. And so the smallest greatest common factor is x squared. Start dividing. X cubed divided by x squared is x. Negative 4x squared divided by x squared, the x squared cancels, so it's just negative 4. Then in here, we don't have a number that goes into both 2 and 1 other than 1. And it doesn't have a variable in here, so that's all. 2x divided by 1 is 2x. 1 divided by 1 is 1. The point here with grouping is that these be the same. They need to be exactly the same, but they are not. So that means that it's not helpful to do grouping because it's not going to create two different factors. Okay, these have to be the same to be one of my factors, and then you get the ones outside to be the other factor. They're not the same, it won't work. So guess what we're going to be using. So the first thing was GCF, or greatest common factor. The next one is synthetic division. And remember that we have to look for factors of 1. So it can be positive 1 times positive 1 or negative 1 times negative 1. And you can start with whichever. That way you can try to see which of the two, if any of the two, will be a factor. So let me start with x plus 1. Okay, when I have x plus 1 to see if that's one of my other factors, that means that I'm going to be dividing by negative 1. It's the opposite of this. Okay, synthetic division, you put the coefficients, so the 1, the negative 4, and you're gonna say, oh, but this was like 2 units ago. The positive 2 and positive 1. So you're just putting the coefficients and the constant in here. You're dividing by whatever you're trying to see if this is a factor. We're just trying to see if it's a factor. If it doesn't give us 0 in here, then this is not a factor, okay? And so this is how we do it. If you remember, bring down the 1 and then start multiplying these two. Okay, so negative 1 times 1 is negative 1, and we put it up here. We combine this, negative 4 and negative 1 is negative 5. Then again, we multiply this times the negative 5. So negative 1 times negative 5 is positive 5. We combine these two, so 2 plus 5 is 7. Multiply again, negative 1 times 7 is negative 7. Combine 1 and negative 7 is negative 6. So no, this does not work. That's not a factor. Let's try with x minus 1. Okay, so if this is negative x minus 1, my divisor will be positive 1. Again, let me bring down the coefficients. So it's 1, negative 4, positive 2, 1. Bring down the first one and then start multiplying. Okay, 1 times 1, 1. Combine this, negative 4 and 1 is negative 3. 1 times negative 3 is negative 3. Combine 2 minus 3 is negative 1. 1 times negative 1 is negative 1. Combine is 0. So yeah, that's another factor. We have the x. That's one of the factors. We have x minus 1 because we got 0 in here. That means that it's a perfect divisor. We giving us a whole factor without fractions. And so this is how you do it. If this was x cubed, then the first term that we're going to have in this factor is x squared, the next one. Okay, so we put 1 x squared. Remember that the coefficient 1 is not needed. Negative 3x and negative 1. So those are my two factors. When I divided that, these were the two factors. From that first equation that we got, first we cancel. Now we have found 1, 2, 3 factors, but we want to see if we can still factor these even more. If we're looking, we already did GCF and found that one. So for this one, the list is like this. Find to see if it has a greatest common factor. It doesn't. If it's a perfect square, a special square, I should say, because it can be a special, the special square can be a perfect square, or it can be a difference of squares. No, it's not, because one is a perfect square, but it needs to be positive, and so that doesn't work. What if we do the diamond? Will be the next try, diamond. Well, the diamond, or even directly, we're looking for two numbers that multiply equals -1. But when we subtract them, this tells me that we subtract them. If it was positive, it tells me that we add them. When we subtract them, they have to be equals to -3. And the factors have to be, to make it -1, it has to be +1 times -1. And together, when we subtract them, that's equals to 0. So no, it doesn't work. So no, diamond doesn't work. The next possibility is the quadratic equation, which is going to work. Quadratic equation. So far we have done greatest common factor, we have done synthetic division, and now we're going to use the quadratic equation. So the quadratic equation is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. And that song is just so that you remember it. I know it gets annoying when you hear it over and over, but it helps a lot when you're trying to remember on a test. The song comes and then you remember the letters. What is A, B, and C? A is always with the coefficient of x squared. In this case is 1. B is always with x. The coefficient of x is -3. It includes the sign. And C is the constant. So C is -1. And so I'm just going to be replacing these values in my quadratic equation. So x is equals to -b. B is negative. But also we have in here in the formula that we have -b. So it's negative from the formula and -3 from B. Then you can put it in parentheses or not, it's up to you, but we need to multiply those signs in the next step, okay? Bring down the plus minus, bring down the square root. B squared is -3. Because it's negative, we're going to put it between parentheses. -4 is always part of the formula because it's always there, times A, which in this case is 1, times C, which is -1. And I'm squishing it in here. All over 2 times A, which is 1. Okay, so you're just replacing your A right here and right here, your B in these two places, and your C right here, which is -1 is right there. Then we start simplifying each part. The things that I can do at the same time is these negatives. I can also raise this to the second power, and I can do this multiplication and this multiplication in this step. So negative times negative becomes +3 plus minus the square root of. I can simplify -3 squared. It means -3 times -3 is +9. In here, I'm going to multiply all three factors. So -4 times 1 is -4. And the result of those two times -1. So -4 times -1 will be +4. 2 times 1 is 2. Then we bring down the 3 plus minus the square root of. Now what I'm working with only is simplifying that part. Let me move it up. And 9 plus 4 is 13. Divided by 2. X is equals to 3 plus minus. We take the square root of 13 there. 13 square root is 3.6, about 3.6, then divided by 2. And now what we're going to do is that we're going to add 3 plus 3.6. We're going to get two different answers. 3 plus 3.6 is 6.6 divided by 2. Or we also have, because it's one time with the plus and one time with the negative. Now with the negative, 3 minus 3.6, that's going to be -0.6. Basically the -3 with the +3 cancel and you just end up with negative 0.6. and divided by 2. It's two different answers, okay? Finally, 6.6 divided by 2 is 3.3. The other answer is negative 0.6 divided by 2 is negative half of 6 is 0.3. And if you notice, you have, for the answers that we found on the graph with Desmos.com, and it's not a commercial, but it's very helpful, 3.3. The other one is negative 0.3. 0 and 1, how do we find that? Let's go back here. So with this one, we directly found the solutions, okay? Directly found the solutions, which were 3.3, right here, 3.3, and negative 0.3, okay? These two. For these other factors, we are not going to find it directly. You have to solve for each factor, okay? Because if at the beginning we're equaling it to 0, that means that one of the factors have to be 0. When we're multiplying, one of the factors have to be 0. So we get each one, x equals 0, x minus 1 equals 0, and we start solving, and I'm supposed to let you see. With this one we cannot solve because it's already x equals 0, right? We've got that factor equally to 0. We got the second factor equally to 0 and start solving. So if we're subtracting 1, the opposite is to add 1, and so x equals 1. That's the other solution. And so with the quadratic equation, again, these were the two solutions. With the factors, you have to equal each factor to 0 and start solving to find the solution. Okay, let's go check. With technology, those were the solutions. Negative 0.3, right there. Then this one, 0. It's right there. 1, it's right there. And let us move the other one. 3.3, it's right there. It's just that in here we have it rounded to the tens, okay? But that's how you find the solutions with algebra, using your algebra, okay? And this is how you find them using technology. In this case, Desmos.com. And last but not least, I just want to point how amazing this is that we're reviewing and applying, and admire and get amazed of how beautiful it is when different concepts come together to be able to solve this wonderful long function or equation. Okay, here we have another function, and what we're going to do, again, we press the keyboard and we're going to write whatever is on one side of the equation, and we have the absolute value of a trinomial. So we press the absolute value, x squared, so x, this time we can use a to the second power, and then we press plus 2x minus 3. I want you to see right now how it looks. That's just that graph right there, the blue one, okay? And I'll explain this abstract part. Okay, so it's 1/2 means 1 divided by 2. And you can see that Desmos even puts it as a fraction. Since you have the cursor right now in the denominator, you need to move it out of there by pressing this arrow. And then you're going to put x, otherwise your x will appear in the denominator. That's completely different. And then you have plus 3. plus 3, right there. So what are we looking for in our graph? What we're looking for is just the x values of where the two equations meet. Let's look at the objective for today. The objective says to find the solution for sets of any arrangements of equations using technology. And in here, what they're saying, where do the two meet? And again, we're just going to focus on the x, okay? The values for x. I already pressed them in there, so let me put in here, x is going to be about negative 3.3 or negative 3.31, depending on what you want to write. It will also be at negative 2.5. It will be 0. Yeah, 0 comes first, and then this one is for this one. So x is equals to 0. And finally, x will be equals to, it's the x value, not the y. Be careful about that. It's 1.81 or 1.8 if you want to keep it as tenths only, okay? So those are the values that I see in here. Two graphs. This half, which is the absolute value of a quadratic equation, and the other one is a linear equation, so that's a line. Those are the points where they meet. Again, it's just for the values of x that we are going to take in. Okay, let's move this to the side. Okay, so the next process, you need to be patient because it's kind of long but interesting. And so we're going to write this equals to 1 times positive, and this equals to 1 time negative. And you can change this to positive and 1 time negative. So you can change it either here or here. I'm going to change it to do the procedure in here, but when we're looking at the graph, it will be easier if we had that negative. For now, since we're being in the previous lessons with absolute value, what we've been changing to negative is this part for the second time. That's fine. So let's see. We're going to have x squared plus 2x minus 3. Remember that whenever you have absolute value, get that inside of the absolute value equals to exactly the way it is in here, 1/2 x plus 3. And then we're going to do the same thing, but now this will change to negative. So x squared plus 2x minus 3 equals 1/2 x, negative 1/2 x, negative 3. So all you're doing is changing the sign of every term. Okay, changing the sign, not putting it negative, changing the sign. Okay, now that we have that, we start working with it. The first thing you want to do is make it equal to 0. So minus 1/2 x minus 1/2 x. And you can also get rid of this positive 3 by subtracting 3 at the same time. This cancels because that's what we want. We want 0 over here. What do we get on this side? We bring down the x squared. 2x minus 1/2 x. If you can picture two entire cakes, taking away 1/2 of one of those cakes, you end up with 1.5 cakes, right? 1.5. Or another way to see it is 2 minus 1/2, right? 2 minus 1/2. Put it over 1 and then make it into halves by multiplying by 2. If you multiply this times 2, this will be times 2 as well. And you get 4, because 2 times 2 is 4. 1 times 2 is 2. Subtract the 1/2. And once we have common denominator, we just subtract 4 minus 1 is 3. And keep the common denominator. So the same thing as 1.5 or 1 and 1/2 or 3/2 is the same thing. Okay, plus 3/2 x. And then negative 3 minus 3 is negative 6. Now, just like in the first in the first example, we are going to use the quadratic equation because this is not going to give us a perfect 3/2 when we multiply two numbers. So let's just start with the quadratic equation. A will be 1, B will be 3/2, and C will be -6. One thing that somebody asked me, teacher, is it okay if I convert it to decimals and work with decimals? I said, that's fine. Fractions or decimals, they are both lovely. And don't laugh because I'm being serious. Okay, so what is the quadratic equation? X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. X is equals to -b, which is 3/2, plus or minus the square root of b squared, which is 3/2 squared, minus 4ac. Minus 4 times a is 1, c is -6, all over 2a. 2 times a, which is times 1. And so x is equals to -3/2 plus minus, when we're squaring something like this, it's just going to be 3 times 3. 3 times 3 is 9. 2 times 2, which is 4 for the denominator. And then, so basically we're doing this part, and this part, right, at the same time. In here, we're multiplying all three of them. So negative times positive is negative. Negative times negative is going to be positive. And now that I multiply all the signs, I just focus on the numbers. 4 times 1 is 4. 4 times 6 is 24. Or you can just multiply each one, including the sign. -4 times +1, -4. -4 times -6, +24. Divided by 2 times 1, which is 2. And we keep it as -3/2 plus minus the square root of. And in here, I think I recommend that you divide and then add to the 24 to make our lives easier. So 9 divided by 4 is equal to 2.25 plus 24 is 26.25. So 26.25. All divided by 2. Now in here, this means -3 divided by 2 is -1.5. Since we're working with decimals already, it's more convenient to convert that to decimals as well. You can just say 3 divided by 2, if you're not sure, is 1.5, okay? But because it's negative, you just bring down the negative. Plus minus, we can already take the square root of 26.25. So press 26.25. Press the square root. Remember that in some calculators, first you have to press the symbol and then the number. Like in this one. You cannot see it because there's no light in there. So in here, you press the square root first and then 26.25. And then you press equal and you will get the same answer. See? But here you first press the square root. And this one, you first press the number and then square root. And the answer is about 5 point, I don't know what to put, 5.1. It's just rounded, okay? Divided by 2. And so in here, what we're going to do is get this number. First, you're going to add that to 5.1. In reality, subtract because you have a positive and a negative. You subtract and leave the greater sign. Okay, so 5.1. 5.1 minus 1.5. 5.1 minus 1.5 is 3.6. Which one is greater, the negative or the positive? The positive, so it's 3.6. Okay, 3.6 divided by 2. Let's divide it by 2. Divided by 2 gives me 1.8. 1.8. The other solution is with the subtraction. Again, subtraction doesn't necessarily mean subtraction, because you have negative 1.5 and negative 5.1 is like addition of negatives. You add them. Okay, so this is the other possibility now with the negative. So 1.5, and it's negative, so I'm going to press this symbol right here. That makes it negative, and then minus 5.1, minus 5.1. It's negative 6.6 divided by 2. Remember that these are two different solutions. Divided by 2 gives me negative 3.3. Okay, so those are two solutions. And so now we have to find the other two solutions when we have the negative of the answer. At the end, we'll compare the answers that we get here to the ones that we got in the technology. Okay, so in here, again, now we change the answer to negative. And so we start canceling now by adding 1/2 of x and 3. That way this cancels and this cancel. But if we add it on one side, we have to add it on the other side. Okay, in here we're going to get x squared, 2x, and 1/2 x is 2.5x. Or you can put it as, let's transfer into 2 wholes plus 1/2. We convert that to halves. Multiply by 2, multiply by 2. 2 times 2 is 4. 1 times 2 is 2. And add it to 1/2. So this means the 2 whole pies became 4 halves. And now we're just putting together all the halves. You have 4 halves in the 2 whole pies. And one more, it's 5 halves. 5 halves. Again, when you have the common denominator, all you do is add the numerators and just bring over 2. So 5 halves x, and then negative 3 and positive 3 cancel. So that's how we get an equals 0. Again, because we know how to work with different types of processes, in here, since I don't have a trinomial, I only have 2 terms and both have x, it's easier to just get the greatest common factor. Both have x, so x is going to be my greatest common factor. And then start dividing. X squared divided by x, x. 5 halves x divided by x, the x cancels, and I just end up with 5 halves equals 0. Now, each factor, we're going to equal it to 0. So x equals 0. And also x plus 5 halves equals 0. We cannot do anything else because there's nothing to cancel next to x. But in here, if we're adding 5 halves, we're going to subtract 5 halves from both sides. This cancels, and x is equal to 0 minus 5 halves is negative 5 halves. So this is my other solution. So now I have all 4 solutions. Those are 2 of them. These are the other ones. And now we can compare it to our graph. But before we do that, because they appear as decimals in the graph, let's simplify this. Negative 5 divided by 2 is negative 2.5. Okay, negative 2.5. And if you notice, those are the values that we got from our graph on Desmos. So look at that, negative 3.31, negative 3.3. So this is the first one. Negative 2.5 is this one right here. 0 is this one right here. Positive 1.81 is this one right here. Again, these are rounded to the tenths. This was rounded to the hundredths, but you get the same answers, right? Now let's just sketch the in your homework, you can do it in whichever order. You can do the first the algebraic and then the graph, the sketch of the graph, or you can just sketch the graph and then prove it with your process. Okay, so for our graph, not for the graph, for the sketch, it's a +1. Okay, I wasn't able to touch it. I'm not sure what was going on, but okay, so here it is again. I turned it around to make it easier. The values for x are 1. Then you have it at -3. So 1, 2, 3, -3. But those are not the values that we're looking for, okay? It's where the two equations, where the two arrangements meet. This is just to guide me. I'm just pressing those so that I can be guided to create my graph. And then I noticed that this is at -1, +4. So 1, 2, 3, 4. It's around here. So that's just to create this curve right here, okay? So something like that, more or less. Yikes. And then you have it going like that, okay? And it's something like this. And for this side, it goes past the 4, so something like that. Something that I want you to see is that this is a parabola, or part of the parabola. X squared plus 2x minus 3, that's a parabola. And when it's positive, this is my parabola right here. This is my parabola right here. However, because it's inside of the absolute value, it can only be the positive part, and that's why that one disappeared. And then remember that we changed the signs in here. We could have changed it to -x squared minus 2x, and then change it to +3. Instead of changing the second one that we did, we changed this to negative. But we can also, instead of changing this one, we can change this to negative. So 1 time positive, that's my graph right there. But without this part, because it's the absolute value, it can be only the positive values. So that's that part. For the negative, when we changed it to the negative, these negatives could have been in here instead. Okay, switch it to the opposite sign. And that's this graph right here. That's when we have a -a, the graph faces down. However, this gets eliminated because it's the absolute value. We cannot be negative. In the negatives on y, that's why that part disappears. What do you end up with? Just this figure right here. This part right here, this part right here, and this part right here. Okay? Now for this line, it just means this is my initial point. So 1, 2, 3, right there. And then it goes 1 up, 2 to the side, 1 up, 2 to the side. So, and then 1 down, 2 to the side, 1 down, and 2 to more or less, okay? This is my graph for the other one. It's a sketch, okay? And so what are those values in here? Because we're not looking the 1 up, 1 down. No, we're not looking for the points where created by the slope. What we're looking for is these points right here. This point right here, this point right here, this point right here, and this point right here, where the two graphs meet, the two arrangements. And so this is just a sketch. This is going to be -3.3, right? -3.3. I guess it's supposed to be closer, but this is for x is -3.3, comma something. And then for this one is -2.5, -2, -2.5 is this one right here, -2.5. And then for y, it's another value. And then this one is 0. 0, we can see that it's at 0.3. Okay, but that's not what we're looking for. We're just looking for the x value. Okay, just the x coordinate of the whole coordinate. We're just looking at the x. And then for this one is 1.80. That means that this graph should be closer to here. Okay, around here. But that's the value for 1.8 or 1.81. Okay, so 1.81. Again, you can round it to the hundreds or to the tenths. That's fine. But yeah, that's how you use Desmos, or any other technology that will help you see or find those values. Okay, that just helped me guide myself, but what matters is the x values were these 4 points: 1.81, 0, -2.5, -3.3. What can I say other than it was exciting to use technology to prove the answers that we can get algebraically? Not only that, but a lot of lessons came together to find the factors as greatest common factor, the quadratic equation, synthetic division. And so it was nice to have that all together. If you do need to review those topics, let me know. I'll link some of the videos in the description of this video so that you can have access to those, and I'll write the topic and then the link to the video so that you can review those if you find it difficult to understand in here. That way it becomes easier. Now, if you can support the channel, giving us a thumbs up will help a lot. Also subscribing. This will be the link to the entire unit, and here you will find the next lesson. Now you're able to do 5.8 and have fun.